Okay, good morning, everybody. Today we're going to do a review for the exam, which is on Monday. So maybe let me start by writing that down. We have an exam Monday, and the day that is going to be, what, the 21st? So first of all, it'll be available from 9 a.m. to 9 p.m. So please notice that this is different than the usual turn-in time. Usually I say, okay, whatever, just put it in by 11:59. I want you to turn it in by 9 p.m. that day, just so we don't run into any midnight confusion. Okay, so 9 p.m. that day. You may use handwritten notes and the textbook. Using other resources, including other websites, other people, other textbooks, etc., is cheating. So if you want to read up on the policies in our syllabus on academic dishonesty, you can do that. I hope that this won't be an issue. I don't think it will be an issue. Let me make this full screen. That better? Okay. What else about the exam? It covers everything that we've done so far, up to 2.2 is the last section that we did. You must submit your exam as a PDF. So if you don't have a scanner that'll scan to PDF, you can use an app on the App Store. There are several that you can take pictures of your paper and it'll combine it all into one PDF and you can submit it onto Blackboard. If you want to, I will leave enough space on the exam that you could theoretically print it out and write on the exam sheet. But if you'd rather work on scrap paper, then you can work on scrap paper. Just make sure that all of your work, it's clear what problem you're working on and everything's in order and I can tell what's going on. If I can't tell what's going on, then I'll email you about it and we'll figure it out. Okay, I think that's all I have to say about that. Are there any questions? Okay, what I had planned for today is I'm basically just going to go through some of these chapters and let you know what you should know from each section for the exam, and then after that I'll take questions from you guys. If you guys don't have questions, then I'll pull some random problems from the book and do them. Okay, so that's the exam stuff. So the following is a list of things you should know for the exam. Parentheses, this list is not comprehensive. You should know, in principle, how to do everything that we did in lecture. So if you want a comprehensive list, then you can watch all of the lectures. This list is going to give you probably most of the things that you could see on the exam. Okay, so section 1.1 was on functions. And I recommend that you know the definition of a function. Know how to tell if a graph represents a valid function. How do we do that?
Vertical line test.
Vertical line test. By the way, if my handwriting here gets out of control, just let me know and I'll go back and write things. Okay. So, know how to use the vertical line test. You should also know how to tell if it's a function. If a table of inputs and outputs is a function. You should definitely know how to do that. Let's see here, make sure I'm not missing anything. Ooh, you should know what it means for a function to be increasing, respectively decreasing. All right, that feels pretty good. All right, section, how's it writing? Okay, section 1.2 was on linear functions. Know y equals mx plus b and how to use it. Know how to use, it's a bad U, use slope-intercept form with different variables other than y and x. Okay, on the homework there was one with p and q. Should know how to use all kinds of different variables. Know how to find the slope and what it is / means. Should know how to find horizontal and vertical intercepts for a linear function. I'll put on here recommended. I recommend. Oh geez, how do I spell recommend? Is it 2 M's? I think it's 2 M's. Did I do it right?
Yeah.
Oh, thank God. Okay, recommend id. We'll put id. Recommended. I recommend that you know how to use point slope form. In theory, you should be able to get away without ever learning how to use this, but it'll make your life easier in some cases. So remember what point slope form was y minus y1 equals m times x minus x1. Questions so far? Okay, I'm just going to keep trucking then. Section 1.3 was on average rate of change and relative change. So if you remember, average rate of change is the slope of the direct path between 2 points, and relative change was like the sale price or the markup percentage. Okay? So you should know the formula for average rate of change. Sometimes I write it AROC. And that formula is average rate of change equals delta y over delta t. In other words, f of b minus f of a over b minus a. So let me complete this statement. No formula for average rate of change of f of x on an interval a comma b. That's a more complete statement there. Okay, so we just find this formula here. It's the slope of the direct path between the points a comma f of a and b comma f of b. This delta here, remember, means change in. Okay, so change in y over change in t. Okay, if we're using different variables, really what this is saying is the change in height of our function divided by the change in width of our function. In other words, rise over run. So this should be cluing into your brain as the slope of a line. It is a slope of the line. It's the slope of the line that takes the direct path between 2 points. So maybe I'll do a quick drawing. If this was f, then it would be, and here was a, and here's b. Then this number would represent the slope of this line, which comes through both of those 2 points. That represents the average rate of change of the function on that interval. Oh yeah. Know how to tell if a function is concave up or concave down just by looking at it. Remember, my trick for that was if we write the word up versus the word down, this is what it looks like if we're concave up, and this is what it'll look like if it's concave down. Know that average velocity is the average rate of change of the distance function. Okay, so if we want to know the average velocity of our car on some interval from A to B, we just take the average rate of change of the distance function, where the distance function tells us how far we are away at time t. Okay, let's see here. We should know the formula for relative change. When I write these down, by the way, and I say no formula for relative change, what I mean is know how to write down the formula, know how to use it, and know what it means, and know what the component parts represent. So that formula was, if you remember, P equals, or relative change in P, is equal to change in P divided by original value of P, which is equal to P1 minus P naught divided by P naught. Okay, so P sub 0, we call it P naught, that's representing the original value. P sub 1, that is the value at time t equals to 1. That's representing our new price or something like that, or new value. Okay, that's all for 1.3. One 1.4 was on applications to economics. Know how to find cost, revenue, and profit functions. Okay, you should know how to find those functions. Know how supply and demand react to price of a good. In other words, if the price goes up, then the demand goes down, so on and so forth. And know how to find marginal cost, revenue, profit. Okay, those are just going to be the slope of our cost, revenue, and profit functions, respectively. One 1.5 was exponential functions. Okay, first of all, we should know P equals P naught a to the power t and how to use it, / what each component part represents. You should know a larger than 1 means we're growing, and a less than 1 means we are decaying. Know how to tell if a graph or a table of values represents an exponential function. One 1.6 Logarithms. Maybe I should pause. Are there any questions so far?
I have a question.
Yes.
Did you write the test, or is this like, are we doing the same test that all the other math 1.2?
I'll be authoring your test.
Okay.
Yeah. Okay, 1.6 was on logs. We should know the corresponding logarithmic equation for an exponential equation. Namely, if e to the x equals a, then ln of a equals x. Know that ln of x and e to the x are inverses, and know what that means. In short, it means they undo one another when we plug them in to each other. Okay. Obviously, we should know how to compute logarithms as well. So 1.7 was, what was 1.7? I think that was like continuous interest. Oh, doubling in time and half-life. Okay. I'm going to say more exponential stuff. Know how to do doubling / half-life problems. Parentheses, especially when we don't know what P naught is. Those are the problems that I see students struggling with most in office hours and in emails, etc. People really struggle when P naught is not given in the function, and we're supposed to find out, say, what the percent rate of decay is or something like that. Oh, okay. No P naught e to the kt and when to use it. The time we use P naught, P equals P naught e to the kt is when we are compounding. What's the word that should go here?
Continuously.
That's right, continuously. Okay. We should also know how to convert between P equals P naught a to the t and P equals P naught e to the kt. There's also one more thing that I should have put up here on exponential functions. We should also know a equals 1 plus r. That's also important. Okay, 1.8. Transformations. And composition. Know how to compose functions, i.e. plug them into one another. You should also know how to do compositions using a table, where we traced through the table of values. You can find lots of examples of that in this lecture. You should also know graph transformations. Shifts, stretches, shrinks, reflections, etc. .9 was power functions, polynomials, proportionality, that sort of thing. We should know how to identify a polynomial, power function, quadratic polynomial, etc. You should know, in general, if I look at some function, I should be able to say, is it a polynomial, is it a power function, is it a quadratic? And if I were asked to provide one of these functions, I should be able to come up with one, such as the problem that was on the practice exam. We should know how to solve for the roots of a quadratic using the quadratic formula or factoring. We should know what it means for y to be directly proportional to x. It means basically y equals k over x, where this k here is called the quote constant. Oh, I'm sorry, this is inversely proportional. It should be k times x, where k here is called the quote constant of proportionality. Should also know what it means for y to be inversely proportional to x, namely that y equals k divided by x. So in the first case here, where we're directly proportional, if x increases, y should also increase. Okay? Or in the bottom case, if x is increasing, y should decrease, right? If we have a number with a larger denominator, it's going to be a smaller number. Okay. So that's it for chapter 1. Section 2.1 was on instantaneous rate of change. You should know that the instantaneous rate of change represents the slope of the function at a given point. We also call this value f prime of that point, which we'll call it a. So f prime of a, instantaneous rate of change of f at a, slope of f at a, we're talking about the same thing. Know how to find it. Find it, by it I mean instantaneous rate of change. Okay, by taking the average rate of change of 2 points, which are closer and closer together. Right? We did that process in class. Okay, I think that's it for that. Lastly, section 2.2. What did we even talk about in 2.2? The derivative function. Know that the derivative is a function. And f prime of x is equal to instantaneous rate of change of f of x why don't we say instantaneous rate of change of f at x. Okay, that's what it means. We should know f prime greater than 0 means we're increasing. F prime less than 0 means we're decreasing. F prime equals 0 means... Okay, I better be careful here about what I'm saying. When I say f prime greater than 0, what is increasing? Blank is increasing. What should I put in there? If f prime is larger than 0, then f is increasing. F prime equal to 0 means f is going horizontally. Okay, so there's a relationship between these two functions. All right, lastly, I think probably know how to sketch f prime if you know what f itself looks like. Okay, that took me longer than I thought it would take. Kind of done a lot of stuff so far. Are there any questions about like the content that you should know for this exam? Okay, then did anybody bring a question that they want me to cover? Yes, Ashlyn.
For section 1.5, when it says a greater than 1 is, so does that mean if a is a positive number, it's growing, and then if a is negative, it's decaying?
For section 1.5, when I say that A is larger than 1, it's growing, A is less than 1, it's decaying. I think what you are confusing this with is A larger than 1 and growing typically corresponds with an R value, which is larger than 0, in other words, positive. And decaying corresponds with an R value, which is less than 0, in other words, negative. So R is going to be, remember, our percent interest or something like that. And the way we get A is by taking R and adding 1 to it. Okay? A itself will never be a negative number, but R might be. Did I answer your question completely? Ryan?
And P naught times e to the kt.
Mm-hmm.
How do you know if it's increasing or decreasing?
Great question. The same way that we know whether this formula is increasing or decreasing, except in this formula we would look at whether R is larger than 0 or R is less than 0. To tell whether we're increasing or decreasing with e to the kt, we would have if k larger than 0, we're increasing. If k less than 0, yeah, we're decreasing. Good question. Derica, did you have a question? Oh, you're good. Anybody else have questions? Yeah, Kevin? How do you find k? Typically, it'll be given to you in the problem. If they say, for example, this bank provides an interest rate of 5% compounded continuously, that's telling you k is equal to 0.05. Okay, so if it's given in the problem. If it's not given in the problem and they expect you to find it, well, maybe we should do an example. Does anybody else have questions before I go into that example? Okay, so let's try it. So suppose you deposit $1,000 in a bank and earn interest continuously. I'm just making this problem up on the spot, so the numbers might not work out so nicely, but let's say in 5 years, you have $1,300 in your account. At what nominal interest rate are you earning interest? Is this the type of problem that you have in mind, Kevin? Okay. So the fact that the problem says I'm earning interest continuously, that should go off in my head as, oh my god, I need to use this P naught e to the kt formula and not the A formula, okay? So I know that P, whoops. Oh god. Okay, let's use P. Come on. P equals P naught e to the kt. I'm tasked with finding out what k is. Can you tell me what P naught is? Anybody? Yeah, $1,000. Okay, and what other information is in the formula, or in the question? We have this part. In 5 years, you have $1,300. How can I write that down mathematically? Dylan.
It's going to be 13,000 is equal to 1,000
Exactly. Perfect. That's how we take that information. Okay, so we really use this p not equal to 1,000 here to say, okay, p is equal to 1,000 e to the kt. And what this green piece of information is telling us is that an ordered pair on this graph is the ordered pair 5, 1300. Okay, so we put 1300 on the left-hand side, and we plugged in 5 for t. And now we're trying to figure out what k is. K is in the exponent. I have an unknown in the exponent. What am I going to have to do? Yeah, I'm going to have to use natural logs. I think the easiest way to do this is to first divide out the 1,000. Okay, you can do it in either order if you want, but I think it's easier if we divide that out. So if we divide both sides by 1,000, we get 1.3 equals e to the 5k. So now we're going to take the natural log of both sides to get this power out of the power. So ln of this side equals ln of this side. And what's the nice property of logs that's going to help me out here? I'll keep ln of 1.3 on this side. What do I have on the right-hand side? 5k, and I'm going to put in here parentheses. Well, I'm going to also multiply by ln of e. But we all know that, what's ln of e? 1. Exactly. Because this is ln of e to the power 1, right? Okay, so e and ln are inverses of one another. Okay, so we can also just write this as 5k on this side. Okay, now what? We divide both sides by 5, right? So k is equal to ln of 1.3 divided by 5. So we would plug that into our calculator and we'd write down some number, whatever we got from that. You satisfied?
Yeah.
Okay. I saw you first.
Would you want us to write it like as a percent or just as the decimal that k is?
I'll specify in the problem.
So like, is that the answer to at what nominal interest rate are you earning interest? That's like, that just means 5k.
Right, so okay, if I really wanted to say what nominal interest rate I was earning interest at, what I'd do, hang on here, get up Wolfram alpha, ln of 1.3 divided by 5. What do we get? We get k equals 0.0524729 ... That's what we get. So if I wanted to answer this question completely, I would have to go back and look at what the question's really asking. It says, at what nominal interest rate are you earning interest? We typically express interest rates as something like X percent, okay? So if I got this value down here as 0.0524729, how should I write it? Yeah, I would say my answer is about 5.25% or something like that. Oh. Thank you. Yeah, I would say about 5.25%. Yes?
Is there any way to go from A to K?
Absolutely, there is. In fact, A and K can be called equivalent. The way we go between them is think about it. If we have P equals P naught A to the power T equals P naught E to the K T, E to the KT, the way we go between these two formulas is by setting A equals E to the K. So, let's do it for this one. Let's find the equivalent. Let me see how much time I have. Okay, I got time. Find the equivalent annual interest rate. Okay, so I know that A equals E to the power 0.0525, about. Okay, so what I would do is go into Wolfram Alpha. You wouldn't do this, you'd use your calculator because you're not allowed to use Wolfram Alpha. You do E to the power 0.0525. What do we get? We get A equals 1.053,903. Get that away. Make this full screen again. So that's what we get. So if I wanted to find R, I know R is equal to A minus 1. So R is equal to 0.053903. So my answer to finding the equivalent annual interest rate, I would say the equivalent annual interest rate is about 5.39%. Okay, so there actually is a difference here. We had 5.25% compounded continuously corresponded to an annual interest rate of 5.39%, slightly larger, okay? What this problem is getting at is that if Bank A offers me a continuous rate of 5.25% and Bank B offers me an annual interest rate of 5.39%, then the amount of interest I earn from both banks is exactly the same, okay? Even though these numbers are slightly different, okay? And banks, by the way, will use this information to try to trick you into thinking that you're getting more interest than you actually are. So be aware of that. Any other questions about this interest stuff? Okay, any other questions in general? We got about 2 minutes left, so it should be quick. Yeah?
Can I just see the last note for section 2.2?
Sure, the last note for section 2.2. Know how to sketch f prime if you know what f itself looks like. Okay, so the way I sketch f prime, if I know what f looks like, should be that f prime will be above the x-axis whenever f is increasing. Okay? All right. Well, if there's no other questions, then we'll end for today. I think Aaron might have an announcement.
Yeah, my session, the review session is on Sunday, and it's from 4 to 5:50. I'm gonna send out an email too, but it's 4 to 5:50.
Okay, so review session 4 to 5:50 on Sunday with Aaron in the SI room. If you have other questions over the weekend, I'll be available via email. And if you have like some questions that you want to meet with me in the course room and talk over, then I'll make some time for you guys. I want you guys to do well. So just let me know if there's anything I can do to help you study, okay?